Okay, now parallel lines, a lot of angles are either congruent or they're supplementary. So if you got to figure out the value of x and y, probably look at the x's first. So this angle and this angle, these are alternate interior angles, and alternate interior angles are always congruent, so they're the same. Whatever the size they are, they got to be the same. So this 8x minus 10 has to be the exact same as 7x. So now it's just algebra solve for x. Move these x's over here. Minus 7x minus 7x. So you got 1x minus 10 equals 0. Move the 10 over here. Plus 10 plus 10. So we got x is equal to 10. Okay, now to find y, take that 10 and plug it in. Maybe I'll plug it in right here. So this is 7 times 10. So this angle right here on the right is 70 degrees. So that means this guy right here is 70. So these two are a linear pair. They're going to add and give you 180. So I know that my 6y plus the 20 plus the 70 has to equal 180. So 6y plus 90 equals 180. So now minus 90 minus 90, 6y equals 90. So divide by 6, divide by 6, 90 divided by 6 will give you y. So y is going to end up being 15. Okay, now shape number 2 is some kind of trapezoid. And you got parallel lines. Okay, parallel lines. If you have these lines extended out, this transversal right here, okay, this 120 and this x, these are consecutive interior angles, and they will add and give you 180. So I know the x has to be 60, because if this is 60 and that's 120, those add and give you 180. Okay, now if I know x is 60, I'm going to take it and plug it in right here. So that's 3 times 60 minus 70, and that is 180 minus 70, and that is 110 degrees. So this angle is 110. I know this angle adjacent to it is a linear pair. They got to add and give you 180, so this one has to be 70, because 70 110 is 180. So the 3y plus the 40 has got to give you 70. So minus 40 minus 40, 3y equals 30. So that means y has got to be 10. Okay, now this picture might get a little, I'm going to blow it up so it might be a little easier. Okay, here we go. 11 is 62. So 11 right here, this is 62 degrees. Okay. 14 is 38. So 14 right here, that's 38. Alright, now I gotta find all the others. And these two lines are parallel. So if that's 62, I know 8 is also 62, because those are vertical angles. And then I can find 7 and 12, because 7 and 12 are going to be supplementary to 62. So it's going to be 180 minus 62, and that is 7 is 118, 12 is 118. Okay, the same over here. This is 38, 9 is also 38, and 10 and 13 are going to be 180 minus 38. So this is going to be 142, this is going to be 142. Okay, so far we just got the bottom 8 angles, and that's not too bad, that's pretty easy. Okay, now this in here, I'm going to find angle 5, because these make a triangle, And a triangle, there's 3 angles, and they gotta add to be 180. So I'm gonna do 180, subtract 62, subtract 38, and what is ever left over has got to be angle 5. So 180 minus 62 minus 38. Let's see. Okay. That's gonna be 80. So 5 is 80 and 2 is 80 because 5 and 2 are vertical, and vertical angles are congruent. And we are almost done. Okay, 11. I can look at 11. 11 is going to be congruent to 3. Is that right? 11 and 3 congruent. Maybe they're not. Because I'm looking at this right here. If I've got parallel lines and I've got a transversal right there, this is where 11 is. And this is where 3 is. Yep. So 11 and 3 are going to be alternate interior. The problem is I've got an extra line that kind of makes it. I've got a line going this way. But this black line, this transversal right here, is not really going to change angle 11 or angle 3. So they will be congruent. So if 11 is 62, 3 is going to be 62. If 3 is 62, 4 is 62. And now I can find 6. I think 1 and 14 are congruent, so I'll bet 1's got to be 38. So you can check it. These 3 have got to add and give you 180. So if you do 38 plus 80 plus 62, it's got to be 180, and it is. So 1 is 38, 6 is 38, and we just found all 14 angles. Okay, number 15. If I give you 3 sides, you got to tell me, can it make a triangle, yes or no? If it can, what does it make? Does it make a 90, an obtuse, or an acute? Okay, so this is the big side, 26, and the rule is these 2 little guys have got to be, if they're going to touch ever and make a triangle, they have got to add together and be longer than the base. And since 13 and 13 is 26, these guys will never ever touch and make a triangle, because they will just fall down to the base and they will touch right here. They're never going to touch except for when they fall on the line. So the 2 little guys, 13 plus 13, has got to add and be more than 26. They cannot be equal to 26. 16. Okay, the big one is 20. So 14 plus 8, that's 22. So it is yes. Now, the big one is going to be C in my a squared plus b squared equals c squared. So let's do 14 squared plus 8 squared. And let's see how it compares to 20 squared. 20 squared is 400. 8 squared is 64. 14 squared is 196. So if I do 196 add 64, I get 260. So my little guys add and give you 260. My big one adds and gives you 400. So 400 is greater than 260. If the big one is bigger than the little ones, that is the definition of obtuse. Okay, now 17. If you have square roots, change them to decimals. So if I do 3 square roots of 2, that decimal is 4.24. Square root of 7 is 2.64. Okay, this one's the biggest. And if I add the small ones, 4 plus 2.64, yeah, that's going to give me 6.64. 6.64 is bigger than 4.24, so yes, you can make a triangle. So this guy's the biggest one. So I'm going to do the little one, square root of 7, squared plus 4 squared, and let's see how it ranks up to 3 square roots of 2 squared. Okay, square root of 7 times square root of 7 is square root of 49, which is just 7. 4 squared is 16. 16 and 7 is 23. Okay, now 3 square roots of 2 times 3 square roots of 2. 3 times 3 is 9. Square root of 2 times square root of 2 is square root of 4. That's 9 times 2. That's 18. Okay, this time the little guys are bigger than the big guy. And when the little guys are bigger, it is acute. Okay, some geometry. Pythagorean Theorem and special triangles. Okay, let's see this perimeter. So if the perimeter is walking around the outside, if you add up all the outside edges, so I need this guy right here. And to find that, if I know that's a 90, that's a 90, I'm going to come and make a 90 and a 90. So I got a little rectangle, so it's 4 along the base, 8 tall, 4 along the base, 8 tall. And then from here to here was 10, but if from here to here is 4, that means from here to here is 6. Okay, now there's my 90 triangle. Now in my 90 triangle, I'm going to use Pythagorean Theorem. If I know that's 6, that's 8, and I got to find that. That's my c, so I'm just going to go 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. That's 100 equals c squared. Square root. That's now 10. So the perimeter, I'm going to do the hypotenuse, that's 10. Add this piece, that's another 10. Add this piece, that's 8. Add this piece, that's 4. So 10, 20, and 12. So 32 feet or miles or whatever it is. The perimeter is going to be 32. Okay, this one's awesome. Pythagorean Theorem. But there's variables instead of just numbers, so it's going to be algebraic instead of arithmetic. Okay, so let's do the same way. This is my c, this is my hypotenuse, so I'm going to do the little guy squared, add the little guy squared, equals the big one squared. Okay, now x minus 4 squared is x minus 4 times x minus 4. So we got 8 squared plus x minus 4 times x minus 4 equals x squared. Okay, now you gotta distribute. This was all quarter 2 stuff. So you got 8 squared plus x squared minus 4x minus 4x plus 16 equals x squared. I'm going to combine my like terms. So 8 squared, I guess we can do 64 plus x squared minus 8x plus 16 equals x squared. Okay, now I'm going to move this x squared over with this x squared, and they should zero out. If I minus x squared minus x squared, I'm going to combine this 64 with this 16. Those are like terms. So 64 and 16 is 80. Yeah, 80. Okay, this x squared is gone, so I got 80 minus 8x equals an x squared minus x squared, that's 0. So I'm going to move these x's over. I'm going to plus 8x, so I've got 80 equals 8x. Now I just got to ditch the 8, divide by 8. So x is 10. So that means this guy's 10, and this is 10 minus 4, this guy's 6. Okay, next, you got this trapezoid. Well, we need to find x, y, z, and then the perimeter. So the perimeter you got to add all the way around it. Okay, you're going to start right here. Now 30. That's awesome. If that's 30, draw the whole shape. That is a special triangle. That's an equilateral. So if that guy's 12, that guy's 12, that guy's 6, that guy's 6, this guy's z is 6 square roots of 3. Okay, now we're in business. This is parallel. So if this guy's 90, this guy's 90. And if this is 90, this is 90, because those are alternate interior angles. And if this is 90, this is 90, because those are consecutive interior. They got to add to be 180. 90, 90 is 180. So you have a rectangle. So that means if it's a rectangle, if the top is 10, the bottom will be 10. If the height is 6, this height will be 6. Okay, now since it's a 45, 45, that's a square. So that's 6, that's 6, that's 6, that's 6. And the diagonal, the pattern for a square is 6 times the square root of 2. Okay, so here we go. The perimeter is going to be 6 square roots of 2 plus 10 plus 12 plus 6 square roots of 3 plus 10 plus 6, and that is the perimeter. Okay, now these square roots, leave them out. So 10 plus 12 is 22, plus 10 is 32, plus 6 is 38. 38 plus 6 square roots of 2 plus 6 square roots of 3. That is your perimeter. Because these guys are not like terms. They're different things. So you could change them to decimals, I guess, and add them to 38 and get a decimal value, but you can just leave it like that. Okay, trig. Find the measure of angle A. Angle A, let's make a triangle. So from B, I'm going to come down here. There's my 90, and I can use the grids to count. 1, 2, 3. This is 4 along the base, and the triangle is 1, 2, 3, 4, 5 tall. Okay, now if I'm marking from angle A, this is opposite, and this 4 is adjacent, and so the trig I want to use is TOA, tangent. So I'm going to go tangent from A is equal to opposite over adjacent is equal to 5 over 4. Okay, now I got to solve for A. A's hanging out with trig, and the only way you can undo the trig is to do the inverse. So I do the inverse on that side, and that kills tangent. I do the inverse on this side, so you've got to do the inverse tangent of 5/4, and if you do that, it gives you A equals 51.34. So angle A is close to 51 degrees. Okay, the next one. So you got two Greek letters here. This one's theta, which we know. This one we don't know. This is a new one, but it's different. It looks kind of the same, except for your line's going vertical instead of horizontal. Okay, this is phi. So it says the sine from phi is 12 over 13. That's this guy right here. So you're marking this angle right here. Sine is opposite over hypotenuse. But this one is a problem because this is not a triangle. But you can make it a triangle. So there we go. So now there's your 90 degree. So opposite is going to be 12. So that means this piece is 12. And the hypotenuse is 13. So the hypotenuse is going to be this guy. And it wants to know what is the sine from theta. So theta right here, now you're marking right here. So now we're going to mark this one. So if you mark this one, this is the opposite and this is the hypotenuse. Okay, but because this is a rectangle, if this distance is 12, this distance is 12. So I just need to find this distance. And in a 90 triangle, if I have two sides, I can do Pythagorean Theorem and find the third. So I can go 12 squared plus my opposite squared is going to equal 13 squared. So 144 plus x squared equals 169. Now solve for x. Let's undo the plus 144. Let's minus 144. Okay, so we got x squared is 25. Undo the square. Square root, x is 5. So this height is 5. So that's Pythagorean triple, 5, 12, 13. All sides are whole numbers. Okay, now it wants the sine of theta. So sine is going to be opposite over hypotenuse, so it is going to be 5 over 13. Okay, now you got to draw your own picture. Recommended angle of elevation, so that's looking up, for a ladder used in firefighting is 75 degrees. What height on a building does a 21-foot ladder reach? Okay, so here's a building, some building right in here. Now if you've got a 21-foot ladder and you want it at 75-degree elevation, so let's come back here. Here's your ladder. Your ladder is 21 feet long, and there's the base of the wall. This angle looking up is going to be 75. Okay, so here's my 90, so we can do trig, mark from the 75, so 21 is hypotenuse, this is opposite, this is adjacent, and they want, what do they want? How high on the building does it go? They want this piece, they want the opposite. So we got to use opposite and hypotenuse. That's sine. So you got to do the sine from 75 is equal to x over 21. Okay, now solve for x, so undo the division. Times by 21 times this by 21, so 21 times sine of 75. 21 times sine of 75, and that will reach a height on the wall of a little over 20 feet, 20.28 feet. Okay. High noon, how many degrees does the minute hand travel when it reaches 2:40 p.m.? Okay, on a clock. 360 is a full spin, so if I go 12 all the way around to 12, 1 hour is 360. 12 to 6, that's 180. 12 to 3, that's 90. So the question is, each of these is how many degrees? So 12 to 3 is 90. 12 to 1, 12 to 2. So that is a 90. Now, if I divide it into 3 chunks, that means each chunk, each 5 minutes, is 30, 60, 90. Okay, so every 5 minutes is 30 degrees. So where do we gotta go? We gotta go to 240. So 240, that's gonna be over here. Alright, so 12 noon to 2 p.m. that is gonna be 12 to 1 is 360, 12 to 2 is 360. That's gonna spin 2 times, 2 hours. So I gotta do 360 plus 360. Now I gotta do 40, and 40 is going to be right here to the 8. So I got to add, you can do it a lot of different ways. If I go to the 6, that's 180. From 12 to 12:30 or 2 to 2:30, that's 180. And then I got to go to the 8, so that's a 30 and a 30. So 360 plus 360, 720 plus 180 plus 60, 960. Should be 960 degrees. Okay. Man, I'm running out of time. Okay, let's draw this picture. Lighthouse shines from a height of 91 feet. So here we go. Here's your lighthouse. Depression, that's tricky. That's looking down. So here's the flashlight right here. It normally looks straight across. Your line of sight is straight, but we are, okay, it's 91 feet tall. 6 degrees angle of depression. I am going down, so it's going to shine down, but the angle of depression is right here. From where it should be looking to pointing down, that is 6 degrees. Plum Island Lighthouse, which is 1,800 feet away. So from here to here, there's another lighthouse, and the distance is 1,800. It shines, it's not as tall, it's shorter. It's 34 feet. So let's make its height 34, and it's not as steep. It's only shining, so it normally should look this way, but it's doing a 2 degree. So that's 2 degrees. Okay, which light is going to reach a boat? A boat is exactly in the middle, so halfway between 1,800, let's say, is right here. Let's say that's 900. Alright, so you got two triangles. Here we go. Now this is 6, so that means this is 6. This is 90. That's 34. I want to find the base. And this triangle over here, that's 91 tall. This angle, oh no. This is 2, not 6. And this guy is 6, so that means this guy is 6. Okay, I gotta find this one. So the boat is 900. So let's see what the base is. Okay, the base. I'm gonna mark it from here. If I mark it from here, that's opposite and that's adjacent. Opposite and adjacent is tangent. So I've got to do tangent of 2 equals 34 over x. Okay, I gotta do probably the same here. Tangent from 6 equals 91 over x. Okay, so now I'm going to solve for x. And x on the bottom, that kind of sucks. You really just switch these two spots. So I'm going to times by x. So I've got x times tangent of 6 equals 91. And now I got to undo the times tangent of 6. Divide tangent 6. Divide this by tangent 6. So x is going to be 91 divided by tangent 6. So just switch these two spots. So it's going to be x equals 34 divided by tangent of 2. So now if I do 91 divided by tangent of 6, okay, x is going to be 865.8, and over here 34 divided by tangent of 2, x is going to be 973. So the base of this triangle is 973. The base of this triangle is 865.8, 973.6. So which one's going to reach a boat that's right in the middle? It's going to be this guy. He will reach it and then some. Okay, now I gotta go. So I'll have to record these later and it'll be part 2. So you guys work together, figure them out. I gotta remember what page I'm on. I'm on page 6. So I'll have them on tonight.